This is Mr. Martin. These are the Geometry Honors Notes for Section 11.6. We're going to be talking about area of circles, sectors, and segments. And we're going to look at three examples. And although we're really not going to talk about the area of circles, it's kind of involved. We're mostly going to be talking about area of sectors. And this word segments here, it has a different meaning in this context than what we normally mean by segments, which is a portion of a line that starts and ends at points. So just so we're all on the same page, when we talk about a segment, we're actually talking about this piece of the circle, this highlighted piece. Okay, I like to think about it like the crust of your pizza. So if you cut off that crust, just cut it straight across, right over here, cut that straight across. That crust would be called a segment. Okay, this is a segment of a circle right here. So that's what we're going to find the area of. So in order to do this, what we want to do is we want to draw in two radii. And if I can find the area of the whole segment, so let me highlight that for you. If I can find the area of this whole sector, find the area of the sector, and then subtract out the area of that little triangle in there, I'll be left with the yellow crust. So to find the area of the segment, it's going to be equal to the area of the sector minus the area of the triangle. Okay, the sector is just a fraction of the area of the circle, so that's going to be, and we have 60 degrees over here, so it's going to be 60 3/60ths of the area of a circle, which is pi r squared, so that's pi times 14 squared. So let's take a step back. Why do we know that the radius is 14 given the length of this chord is 14? Well, I know that this arc is 60, which means that this angle in here is also going to be 60. And I know that each of these angles in here both have to be congruent. So since I know the three angles add up to 180, I know that these two angles that are left have to add up to 120, and they have to be equal. So they each have to be 60. So that makes this an equilateral triangle. So since one side's 14, all the sides are going to be 14. So if you need me to explain that some more, feel free to ask me the next time you see me in class. So this will give us the area of the sector. Now we need to find the area of the triangle. Since it's an equilateral triangle, I can use the formula that we talked about before for an equilateral triangle. It's going to be s squared, so 14 squared root 3 over 4. So as always, unless the problem specifically says to answer in a decimal, make sure you answer in terms of pi or in terms of radical. That's called an exact answer. So if we simplify all this, we end up with 98/3 pi for the area of the sector. And then we'll subtract out the area of the triangle, which would be 49 root 3. And then this would be our answer. All right, so again, make sure that you ask questions when you have them. Let's take a look at the next example. So the previous example was nice because the arc that they gave us was 60 and we ended up with an equilateral triangle. This one's a little bit harder. We have an arc of 120, which means that this whole angle here is going to be 120. But if I drop in an altitude here, then I'll divide that 120 degree angle into 260. So I would have a 60 here, I have a 60 here. I know that these are going to be right triangles, so we're going to have 30, 60, 90s, where my 2x is equal to 7. So this side is going to be my x, so that would be 7/2. And then this side here is going to be my x rad 3, so that would be 7/2 root 3. Okay, so when I So I'm going to do the same thing to find the area of the segment. So this piece here is the segment. I'm going to find this area here. So I've got that the area of the segment is equal to the area of the sector minus the area of the triangle. So now my sector is 120 degrees out of 360 times pi times the radius, which we were given as 7, so times 7 squared. And then the area of the triangle, for the triangle now, we're going to use 1/2 base times height because it's not an equilateral triangle. So we're going to have 1/2. And then the base, since one of these pieces is 7/2 root 3, and this other piece here would also be 7/2 root 3, we end up, when we add those together, 7/2 plus 7/2 is 14/2, which is 7 root 3. And then my height is 7/2. So if we multiply this first stuff out, leaving pi out of the calculation, of course, we've got 49/3 pi. And then over here, I'm going to have 7 times 7, which is 49 on the top, so 49 root 3. And then in my denominator, I have 2 times 2, which is 4, so I get 49 root 3 over 4. And here is our exact area of that shaded segment, that piece of pizza crust. Alright, so moving on to example C. This one now is going to get a little bit more difficult because we're not going to end up with a special triangle because we have this angle in here that's 92 degrees. So I'm still going to do the same thing. I'm going to drop down in altitude. So I get 2 right triangles. And then each of these angles here is going to be 46 degrees. And I know that the radius here is 10 centimeters. So I'm going to draw this little triangle here separately. And I've got 46 degrees here. I've got a radius here. I need my height here, which I'll call x. And this is going to be half of the base of triangle ABC. I'm going to call that y. So in order to find out x and y, we're going to have to use right triangle trig. We're going to have to use SOHCAHTOA. So I'm standing over here at the 46. This is my adjacent side. This is my opposite side. This is my hypotenuse. We're going to use SOHCAHTOA. So let's first talk about x. That's adjacent side. We know the hypotenuse, so that's cosine. So I've got the cosine of 46 degrees is equal to x over 10. So I'm going to put that over 1 and cross multiply. I get x is equal to 10 cosine 46, which is about 6.95. And then the y is my opposite, so I'm going to use the sine. So I've got the sine of 46 degrees is equal to y, that's the opposite, over the adjacent, which is 10. Again, put that over 1, cross multiply. Y is equal to 10 sine 46, which is about 7.19. If you're, you probably want to double check, pause the video and double check that you get the same numbers. If you're not, you may not be in degree mode. If you're not sure how to switch into degree mode, make sure that you ask me. Because if you do that on a quiz or a test, you'll get all the answers wrong if you're in the wrong mode. So now we know that this is my height of my triangle here. And then if I multiply this by 2, this is going to be my base. So this is actually half the base of triangle ABC. So we have everything that we need to calculate the area of the segment again. So this pizza crust shaped piece here. So the area of the segment is going to be, so I've got 92 divided by 360 times pi times 10 squared. And then I'm going to subtract 1/2 base times height, so 1/2. And then the base is going to be 2 times 7.19 and then times the height, which was x, so that's 6.95. And then if we plug all this into our calculator, well, let's do this in steps here. This turns out to be 239ths pi, and this part turns out to be about 49.97. And our final answer then becomes about 30.32 centimeters squared. So remember, if units are included in the problem, make sure you include them in your answer. Again, there's a lot happening in one of these problems, a lot of different parts, so make sure you ask me if you are having questions on any specific part, and we'll see you next time.